So let us discuss dimensional analysis for forced convection. The problem goes like this. Find the functional expression for forced convection heat transfer between a fluid flowing through a tube and its valve. The heat transfer coefficient in forced convection is influenced by the tube diameter capital D, fluid velocity U infinity, and the fluid properties such as density, dynamic viscosity, thermal conductivity, and specific. So I can also express that the convective heat transfer coefficient in case of forced convection is a function of diameter d, fluid velocity u infinity, density rho, dynamic viscosity mu, thermal conductivity of the fluid kf, and specific heat. So I can also represent the above problem in this mathematical form. Now all the parameters which are affecting this forced convection heat transfer phenomena are given in the below table. There, the m represents the mass, L represents the length, T represents the temperature, capital T, and small t represents the unit of time. So, different parameters, their symbol, their unit, and their primary dimensions are mentioned in this table. So, very first variable is tube diameter. It will also be a characteristics length. So its symbol is D, unit is meter, and primary dimension is represented as capital L. Then fluid density represented by rho, kg per meter cube, and primary dimension is ml power minus 3. Fluid viscosity, which we are taking dynamic viscosity in this case, is represented by mu. Its unit is kg per meter second, and primary dimensions are m L power minus 1 small t power minus 1. Fluid velocity represented by U infinity, unit is meter per second, and L into t power minus 1 is primary dimension. Similarly, for fluid thermal conductivity, symbol is Kf, heat watt per meter Kelvin, and ml e power minus 3, capital E minus 1 is primary dimension. For heat transfer coefficient represented by small h, unit is watt per meter square Kelvin, and primary dimensions are m small t power minus 3, capital T power minus 1. Finally, the fluid specific heat represented by Cp, it is joule per kg per Kelvin, and primary dimensions are L square small t power minus 2, capital T power minus 1. Now here, in this case, the number of variables affecting the phenomena, that is force convection, heat transfer phenomena, these are represented by small n. They are total 7 in number. And number of primary dimensions represented by small m are 4. What are those primary dimensions? M, N, capital T as a temperature, and small t as a time. As you can see here, all these primary dimensions of all these 7 variables can be represented in terms of ml capital T and small t primary dimensions. Now, based upon the variables affecting the force convection heat transfer phenomena and total number of primary dimensions. Now, according to the Buckingham Pi theorem, which is used for non-dimensionalization, the independent dimensionless group can be given as number of variables affecting the phenomena minus number of primary dimensions. And these independent dimensionless group are called as pi term, and they can be given as small n minus n. So there will be 7 minus 4. So there will be total number of pi terms will be 3, and these can be represented by pi 1, pi 2, and pi 3 independent dimensionless groups. Now let us write the equations for each of these independent dimensionless groups. Now while writing the equations for writing the taking the different variables under these independent non-dimensionless groups, we will be following some of the basic rules of non-dimensionalizations of parameters. So each independent non-dimensionless pi term must contain one geometrical property, then fluid flow property, and finally fluid property. So this way, the different variables are chosen to form dimensionless independent groups, that is pi term. Also, these pi terms will contain total m plus 1 variables, where m is number of primary dimensions. So following these two rules, I can say each pi term will contain 5 variables, out of which one will be geometrical property, another will be fluid property, another will be fluid flow property, and one will be selected variable. So writing the equation for pi term, diameter is taking as geometrical property, density as fluid property, dynamic viscosity as fluid flow property, and once again thermal conductivity of fluid as fluid fluid property, and finally selected variable is luminosity. Now these four parameters will be repeating variables. These are called as repeating variables. So they will be repeated in each pi term with the variation of their exponent. So pi 2 will be d to power e, o to power f, u to power e, kf to power h, and the remaining selected variable is cp. Then the last pi term will be once again e to power I, o to power a, u to power k, and kf to power n, and the remaining parameter the h. This way I can write expressions for different pi terms. In these expressions, d, rho, mu, and kf, they form a core group. They are also called as repeating variable. And u infinity, tp, and h, they are called as selected variable. Okay. After writing these pi terms, here since pi 1, pi 2, and pi 3, they are dimensionless, hence certain exponents are applied. On the repeating variable. Like in each case, we have provided A, B, C, D, E, F, G, H, I, J, K, L. All these are the exponents provided over these repeating variables D, rho, mu, and Kf. So these exponents must be found out. That is, their value must be found out. Okay. So let us do the exercise to find out. So let us first start for the pi term pi1. So for dimensionless group pi1. Now since pi1 is non-dimensional, pi1 is non-dimensional group, its primary dimensions will be m0. Let us first let me write down the group of pi1 as e to power a, o to power b, u to power c, kf to power d, and u infinity. Now here pi1 is dimensionless, so its primary dimensions can be represented by m power 0, l power 0, t power 0, and small t power. The dimensions of d are l. Density can be written as ml minus 3 power b. Mu can be written as ml minus 1 e minus 1 power c. Kf is written as ml small t minus capital T minus 1 over, and finally for velocity as Lt minus 1. Now from there I have got all these primary dimensions from this table. Now separating all the exponents based upon dimensional homogeneity. So first let us write down for m can be written as 0 is equal to d plus c plus d. Let us say it is equation A. Similarly for L, it can be written as A minus 3B minus C plus E plus 1. Let's say this is equation number D. Then for capital T, it can be written as 0 is equal to. Now for capital D, sorry, capital T, it is only minus. So I can also say D is equal to 0. Let's say equations. And finally for time small t, 0 is equal to minus t minus dd minus 1. Let's say this is equation number D. Now solving all these equations to get the values of A, B, C and D exponents. So it is clear T is equal to 0. If I put value of D into this equation, the value of C becomes minus 1. If I put the value of C and D into equation, B, D is 0, C is minus 1. So B comes out, sorry, in this equation. If I put the value of C and D into equation A, C is minus 1 and D is 0. The value of B comes out 1. And if I put the value of A, B, C, D into equation B, A is 1, B is 1, C is minus 1, D is 0, 1. So after solving this, I will get the value of A is equal to 1. Now, let us put the values of all these exponents into the pi term. The pi 1 term will become e to power A means D, then rho to power B means rho, then u to power C is minus 1, that is become minus 1. Kf to power D is 0 and to infinity is infinity. So combining all these terms will give me the pi 1 term as rho into u infinity per u. And if we closely observe, rho into u infinity into d over mu is nothing but RAD, that is Reynolds number. These are the values of pi term. In the similar fashion, let us find out for case 2. For dimensionless term pi 2. First, let us write down the pi 2 can be expressed as e to power e rho to power b u to power, sorry, it is f u to power g af to power h and finally ts selected variable. Now writing all these terms in terms of primary dimensions, pi 2 being dimensionless parameter, dimensions can be written in this fashion. Once again, diameter is L to power E, rho is ml minus 3, f power f, mu is ml minus 1, small e minus 1 to the power g f m l e minus 3 capital T minus 1 power h, and the unit, the primary dimensions of specific as L square small t minus 2 capital T minus 1. Now once again separating the exponents, that is E, F, E, and H for their dimensional homogeneity. So let us first write it down for M, that is mass. So it can be given as F plus E plus H. For length, it is given as you can see here, E minus Df minus D plus H plus, then for temperature time, 0 is equal to minus H minus 1. And finally, for time small ts, 0 is equal to minus G minus Ph minus, let us say this is equation number F E and H. So let us solve one by one. If I put from equation G, H will be minus 1. If I put the value of H into equation H, small h, the value of G I will get as 1. If I put the value of G and H into equation E, I will get the value of F as 0. And if I put the value of FGH into equation F, I will get the value of as so. Let us put the values of all this into pi 2. So pi 2 term can be written as I have the value of this pi 2 e to power 0 to power e is 0, rho to power f is also 0, mu to power g is 1, and f to power h is minus 2. Kf to power is minus 2 and is Cp. So pi term can be written as mu into E over A. And if you remember, is nothing but Prandtl number. Second, pi term is grouped as Prandtl number. And let us find out finally the third. Non-dimensional term pi 3. So first let us write down the equation variable for pi 3. e to power I, rho to power j, u to power k, and kf to power L, and the selected variable is h. Now once again, let us express all these in terms of primary dimensions m0, n0, t0, small t. These are the primary dimensions for phi3 term and can be written as L to power I ml minus power j ml minus 1 power k, and kf is ml t minus 3 capital T minus is L. Finally, the primary dimensions for H are m into T power minus 3, capital T power minus 3. Now, once again, separating the exponents I, J, K, and L for dimensional homogeneity. So for mass m, I can write it as K plus K plus L plus 1. Let's say this is equation I. For length L, I can write it as, sorry, 0 is equal to I minus Pj minus K plus L. Let's say this is equation number J. For capital T temperature, 0 is equal to minus L minus 1. Let us say this is equation number N. And finally, for time T, 0 is equal to minus K, as you can see here, minus K minus 3L minus 1. Minus 3, sorry, minus equation number K and this equation number. Now, from equation K, the value of L will come out minus 1. If I put the value of L into equation L, the value of K will come out 0. If I put the value of K and L into equation I will get the value of J is equal to minus 1. From the equation K, the value of L will be minus 1. Value of K will come out 0. Value of J will be 0. And value of I will be 1. Now, after finding out the value of exponent L, K, J, and I, let us put them in the pi term. So pi 3 will become d to power 1 rho to power 0 mu to power 0 and af to power minus 1 and selected variable h. So this comes out as hd over kf, and it is nothing but Nusselt number. Is nothing but pi 3 term is nothing but Nusselt number. So after regrouping, hence for forced convection, from experimentation it is found that pi 3 is a function of term pi 1 and pi 2. So I can write it as Nusselt number based upon diameter is a function of Reynolds number into Fresnel number. So this is the required relationship between all the parameters affecting the forced convection phenomenon.